So we're going to treat these individually. So y is less than or equal to 3x plus 2. I'm going to treat it like y equals 3x plus 2. So I'm going to go up to positive 2, put my dot. Then I'm going to go up 3, right 1. Up 3, right 1. Up 3, right 1. Down 3, left 1. Down 3, left 1. Down 3, left 1. And down 3, left 1. Okay? But now I got to ask myself two questions. First question is it going to be a solid or a dashed line? Okay? In this case, it's going to be a solid line because it's got the equals component. Okay? If it just had greater than or just less than, then I wouldn't graph it with a solid line. I'd graph it with a dashed line. Okay? Then I have to do a test point. So the second thing I'm going to ask myself is, did I go through the origin? And if I didn't go through the origin, I'm going to test the origin. Okay? So by doing the test point of the origin, that's 0, 0, I am going to put that into my original function right there. So y is 0. If x is 0, then that's going to be 0 and then plus 2. So 3 times 0 is 0, plus 2 is 2. So I need to say, is this a true statement or is that a false statement? 0 is less than or equal to 2. True or false? True. So that means I'm going to shade toward, oops, tap the brakes. That means I'm going to shade to that side of my line. However, because I've got a second one that I need to put on here yet, I am going to just draw some arrows right now. So now I go to the second line, or the second inequality that I have. So y is greater than negative x plus 4. I treat that like it was y equals negative x plus 4. And so I'm going to go up 4 from my origin, put a dot. Then I've got a slope of negative 1, so I'm going to go down 1 and right 1. Down 1 and right 1. Actually, I'm going 2's just because I don't want to make so many dots. Or I can go up and left. Okay? But now because this one doesn't have the equals component to it, I have it as a dashed line. Okay? So I'm there. Then again I ask myself, did I go through the origin? The answer is no, I did not go through the origin. So I'm going to use that as my test point again. I'm going to put it back into my original inequality. Negative 0 plus 4 is 4. And then again I ask myself, is that true or false? Which one is that? False. That one is false. So I'm going to shade away from my test point. The opposite side of my test point is what gets shaded. Okay? But I don't shade yet because now I might have to repeat that for another one if I had a system of 3 equations or 3 inequalities. Or a fourth one if I had 4, and so on and so forth. Okay? Alright? So now my final answer is going to be the section of the graph where both, or all 3, or all 4, or however many I have, arrows are pointing into it. So in this particular case, my section of graph is going to be that whole section over there, because that's where both arrows were pointing. So I shade in that entire section. Okay? gives me my graph. Or my solution, I should say. It's not just one point that you're looking for now. You're looking for a region of the graph. Okay? So this was then number 2 on the back side. So first off, we start with x is greater than or equal to 2. Is that a solid or dashed line? That's a solid line. Okay? What kind of a line is it? It's a vertical line at 2, right? Okay? So that's going to look like that. Did I go through the origin? No, so I can test the origin. So I plug in 0 for x. I plug in 0 for y. 0 is greater than or equal to 2. True or false? False. So I'm going to shade left side or right side? Right side. I'm going to shade on the right side. But again, I don't shade just yet. I just draw arrows. With me. Okay. Second one. Solve for y. So that means I go up 4. Then I go down 4 and right 3. Down 4, 2, 4, 2, 3. 2, 4, 2, 3. 3, 4, 1, 2, and 3. Solid or dashed line for this one? It's a dashed line for this one. Did I go through the origin? No. So I can use the origin then as my test point. 4 times 0 is 0. 3 times 0 is 0. Is 0 plus 0 is 0. Is that less than or less than 12? Yes, that's true, correct? Okay. So I don't really care about over here because that's not going to be in my answer. So I'm only going to, you know what I mean? I'm only going to make my arrows down there because up here, not part of my answer because it doesn't work out with the blue. Okay? Then I go on to my third one. That gives me a y-intercept of -1, a slope of 3, 1, 2, and 3, right 1, 1, 3, right 1, 2, 4, right 1, 3, left 1, left 1. Solid or dashed line for that one? It's a dashed line. Did I go through the origin? It looks close, but I didn't really go through it, so I'm still good. -3 times 0 plus 0 is 0, less than or equal to -1. True or false? False. So I'm going to shade on the opposite side of the line. So that means that I would shade down in this general area right here. So really, my solution area, where all 3 of them show up, is right in there. Okay. Y is less than 2. What kind of a line is that? Horizontal, solid or dashed? Dashed. Did I go through the origin? No. Zero less than 2, true or false? That's a true statement. Kind of a graph is this next one? Absolute value, V for value, so that's going to be an absolute value. Remember that this moves it horizontally and that moves it vertically. So I'm going to move my peak of my V, or peak of my mountaintop, or valley of my V. I'm going to move it 2 to the right and down 1. So that's where my valley is. And then the right side slope is 2. My left side slope is negative 2. Now, what could have I done had I not remembered that? T-chart. I could have made myself a T-chart. Okay? Is it going to be a solid or a dashed V?
Solid.
It is going to be solid. Ooh, that needs to be much thicker. Okay. So then I need to do a test point on that one. So 0 is greater than or equal to 2 times the absolute value of 0 minus 2, then minus 1. 0 minus 2, negative 2 absolute value. 2 times 2, minus 1, 3. So that's 0 is greater than or equal to positive 3. Is that true or is that false? That's false. So where am I going to shade? On the inside of the V below the blue line. So just that little triangle. Okay? Working our way backwards. Okay? So I've got this line, right? This line here has a y-intercept of 3 and a slope of, to me, it looks like positive 1. Do we agree with that? Okay? So this is the line y equals x plus 3. Correct? Yes? Okay? So I know for a fact that it's going to be y and then x plus 3. I just have to fill in that less than, greater than, less than, equal to, greater than, equal to. Okay? So I want my test point of the origin to be true. So if I put 0 and 0 plus 3, I need that to be a true statement with a solid line. So that's going to be that. That gives me a solid line because it's got the equals component, and it gives me a true statement. So there is my inequality. Okay. Expand on that one. Here again, that is a b of 3, a slope of 1. We're shaded below that one. So this one is, again, going to be y is less than or equal to x plus 3. It's the same as this one over here. Okay? But now I added in this other one. This other part here is a vertical line, which is an x equals line at 1, 2, 3. Correct? Okay. If I put in my test point of the origin, I need that to be a false statement. Okay? I need that to be a false statement because my test point is right there, and that is not in the shaded area. So that would be, it's dashed, so that one's going to be that. So my other part here is x is greater than 3. Got to come up with the line first, then you've got to fill in the inequality based upon test points. All about the test point. You will need one piece of white graph paper. This one will be due on Monday. And don't forget,